Hello there. Today we'll be doing an algo called a minimum window substring. This is a pretty interesting problem, our 1/30th problem, which is very nice. In this particular problem, we're looking to find the minimum window at which A, B, and C exists, and that window is a B, A, and C right here. And so window problem, right? We're going to look at the left and right pointer. That's what we're going to do. So we start our pointer here. We move the right pointer until we get all the items in place, right? So we have A, B, and C here. Then what that happens, we can start moving the left pointer. So let's just put this here, left, right. We move the right until this point. We've collected A, B, and C that exist. Let's say a hash map because that way, because order doesn't matter. So once we've found it, let's move the L. And oh look, it doesn't exist anymore. Let's put this on two separate lines. So it doesn't exist anymore. So A has disappeared from our list. Let's have a count of it because we need more than one sometimes. So we have one, whoops, one, one, one. Now we have 0. Then next things next is that we keep moving R so that we can find an A. O, D, E, B, that's 2 now. And A, we found 1. And now we have hit the point where we have 3 total items. Let's say A, B, and C was found, so we have 3. And now we move L again. We move L. We still have 1 B now that we've got to this point. We missed the B now. We move that, and we're losing the C, so we have 0. And that point, it does not match. Let's say what we're trying to match here. 1, 1, 1. All right, so we're not matching anymore. So we have 2 that matches, and that is not enough. So we're gonna keep moving. We're not going to keep moving. I want to move the right until we get a match again, and we can increment this to be 3, and we can check. We can keep moving the left until the point right there where the result length is now shorter, the shortest it has ever been, and we have our answer. So what that means is result was 5 or 6. Then it was 6 again, and then now it's 4. So how do I get those 4? 4 here. I think it was 6 here, and another 6 here, right there. So hopefully that made sense. What transpired. Let's code it out, and yeah, that's it. Let's take a look. So first of all, let's make that hash happen. So hash the T. So hash the T and the window. Then what we're gonna do after that is that 2 increment the R until have equals need. So number of items spent needed to be found. While have is equal to need. What we're gonna need to do there is that move increment L and check for shorter window or smaller window. And once we have incremented all of S, return results. Okay, I think that's it. Those are 4 things we need to do, and let's get it. So let's say count T and count window is equal to, let's say, a default dictionary of int. Same thing here. All right. For C in T, count t plus equals of c plus equals 1. All right, so that's good. We need to also get, so we're going to increment t now. So for r in range length of s, we're going to increment r, well, basically that increments r. And what we need to do is if, let's say, count of t, we have to get the character first. So character is equal to the s of r. And if, let's say, c in count t, then if it's in there, that means that the count window needs to, of the c, needs to plus equals 1. And if, right, so the count of t of c is equal to the count of a window at c. If they're equal, that means that the half is plus equals 1. So we're doing part 2 now and part 1. So right there. So we need have and need. So have and need equals have is 0 and need is length of count t. Okay. So once we have that, we just need to make sure that while have is equal to need, we need to increment l plus equals 1. And we're looking to check a smaller window. So that means a result is equal, and result length is equal to a -1, and result length is going to be equal to the max. And what is the max? Let's set the max here. Max is equal to 101,000 because that's 10 to the 5th power. And right, let's keep moving. And we also need a left equals 0 because we need a left pointer. So if let's say right minus left plus 1 is less than result length, that means that it is smaller window, and that means result length is equal to the new window minus L plus 1, and that also means that the result is equal to left and right. Yeah, we can also use a tuple. I think that makes a little bit more sense what we're doing here. So let's use a tuple for that. All right, with that, we can now make sure that we let's shrink the window. So how to shrink the window, right? So count window of s of l minus equals 1, and if let's say if s of l in count window, then we'll minus 1 because we don't want to subtract stuff that doesn't exist. That maybe that, yeah, that's a problem. So if s of l in count window, and let's say count window of s of l is less than count t s of l, then have minus equals 1. Right, is that it? I think so. So with that, we keep incrementing until we have we drew all of s. So then afterwards we return results, our L and R is equal to result, and we return this particular string, S of L and R plus 1, if res length does not equal max, else empty string. One more thing is that to shortcut some problems is that if t is equal to empty, return empty. I think that should be it. Let's run through the code one more time. So what happened was we start everything at the beginning. L and R starts at the beginning. And we have this hash map with these 0 items in here. And we have 0 halves and a need, right? So let's run through the code. So L and R, that's at the beginning. I think we have all the items in place. And the max has been created, L has been created, R has been created. So we get the first character, it's an A, it's in the window, and so have is plus equals 1 now. It's 1, A is 1, R moves. They're not equal yet, so keep moving forward. The R, they're not in. So now we have 2, we have 1, we keep moving the R until here, and we have 1 here, and then we have 3. While have is equal to need, which is the case right now, if it's less than the length, res length, which is currently equal to like 100,000, and 1, and that is the case. So basically, that means we have to reset the res to be 0 and 5 at this particular location, and this is now equal to 6. Perfect. And is it in the window? Is it in the window? Yes, S of L is in the window. That's A. So we subtract 1, and if it's in the window and it's less than the t, then minus equals 1. So now have is 2, and that means that breaks the cycle, and that's it. And we increment L. So we keep going. We keep moving R until we see a B again. So that increments to 2. Still does not equal need. Okay, A. So A is equal to 1. Now this means that we have is equal to 3. And with that, we are good to go. And we have another window. But that window is, let's say, too big. And so we keep moving the L. There's nothing happens. We found the B. I guess we remove a B. And nothing happens. We're still good to go. The window's still too big, and we get to C, and this window here is also 6 characters long, so nothing changes. We keep moving the L, so the L keeps on moving, loses the C, and we keep going. With that, we keep moving the R now until we got to C. Of course, that means a C is now 1, and the length is now 3, and we're ready to move the L until we hit B. That means that we found the item that's 4 length, so this is now 4, and this is now this particular position to this particular position here. I don't know what that is. Let's just say 9 and 12. And now what happens here is that we found the item, we've updated. Let's keep moving the L, and it looks like we have gone, well actually, well we do keep moving the L, and we have broken the loop, and now this is 2. And with that, we end the loop, and we have finished R, and we have completed, and just code should work pretty okay. Oh, what happened here? Huh, very funny. Okay. Oh, runtime error. integers. Let me print res what's going on. Nine and 12. All right, this is makes sense. All right, so that is the good answer, and let's submit, and I think this is good to go. All right, it was much faster earlier, but it's okay now too. So that's it. That's what we got. I hope you've seen all the code. Shoot, my bad. I don't think you saw this earlier, but it is what it is. I think we incremented through the code once. Sorry you didn't see that, but the moving, but you should have seen the L and the R moving, incrementing the hash map. So that's everything for this piece of code. I think we went over 3 times, and the first time we went over it and we talked about the idea. Then we wrote out what we were gonna do. We did what we were gonna do, and we went over what we did. So I guess we went over it 4 times maybe. But yeah, that's pretty much the sliding window problem. And when this was done in O of n time, we went through window once, and it's cost O of 1 space. Well, not O of 1 space, O of n space. Yeah. But the lookup time was O of 1 because we did not have to go through all the haves and have-nots. So that's all for this problem. If you enjoyed the video, like and subscribe. For more videos, check the link in the description below. Thank you very much, and I will see you in the next one.